Thank you. Well, we brought our own fan crew here up in the front. But we've always done it this way. That's a sentence that's not exclusive to engineering. I'm sure you've all heard it. You joined this new company. You have this really good idea. And then it doesn't happen because we've always done it this way. That is something, as I said, that's not only true for engineering, that also is true for craftsmanship. And I actually believe it's very human. So that's a part of the presentation that we wanted to talk about today. We wanted to talk about how we are digitizing craftsmanship at 1.5 and how we are facilitating a certain architectural pattern or actual multiple and how we combine them in the next 30 minutes.
Hello, I'm Sara. I'm a lead software engineer in the virtual assembly line at 1.5. And I'm here with
Michaelis. I'm the head of engineering at the virtual assembly line 1.5. And we are here because we have a problem we need to talk about. As humanity, we are at a point where we lost things. We reached tipping points. The Earth is warming to a point that in about 10 to 15 years, coral reefs won't be a thing. That's the thing of the past. Like, we're not even talking about can we save that. We're also not talking about can we actually reach the Paris Climate Accord. That ship has sailed, and it's only getting worse from there. Right? There's more stuff we can lose. Like, it's not about, oh yeah, we lost that. Like, now we can just like keep going like that. And at 1.5, that is what fuels us. So here you can see basically a representation of global warming. Every stripe is a year. That's the last 100 years. And the color is the average temperature a year. And as you can clearly tell, there's a problem, right? And we are here to fix it.
And yeah, as Ole said, we are running out of time. And what we're doing at 1.5 is our goal is to build Europe's largest virtual power plant. In our tech team, we have two streams. The first stream is our heartbeat. So that's basically where we provide our customers with the lowest energy price. That's how we want to basically build this virtual power plant. And we also have our VAL, so our operating system for installation companies. That's where we digitize all the operations and all the processes, starting from the ground operations to the rooftop installations.
Yes, and when Sara mentions operating system, don't confuse that with your favorite Linux distribution. That's how we decided to call the application we are building. It's a regular web app. It has a front end in the browser. It's not an operating system. You will hear us saying that word a few times now. Whenever we say that, imagine this disclaimer after us saying operating system, right? It's not an actual operating system. So we want to build this virtual power plant to stop global warming, or to support stopping global warming. It's a team effort, right? We all do that. But in order to do that, we need to do that fast. So, and I'm happy to report that actually 1.5 is pretty successful at it. Here's one recent example. We got a deal with the state of Niedersachsen to actually put our renewable energy systems at all public buildings, which is pretty cool. But it's also a lot of work. Like going on the roof, installing multiple thousands of solar modules is a thing that you just don't do with your regular electrician company. It requires a lot more labor, and just pouring in labor, you know, the mythical man month, 2,000 installers won't install the scaled up version of modules. But fortunately, the founder, Philipp Schröder, he has quite some experience in doing things at scale. In his track record, he's built Tesla Germany. And that is where he liked this or learned about this idea of an assembly line. So what if we can install renewable energy systems like in an assembly line? But we have a problem. If you want to have a renewable energy system at your home doesn't live in our factory, right? You can't just ship it to us, we install it and ship it back to you. That's not how it works. So we need to distribute that. And that is what we call the virtual assembly line. The virtual assembly line is something that's actually larger than what you see here on stage. That is the part that we call the fulfillment part. So we actually consider part of the virtual assembly line the sales process, but that's not what we're going to talk about today. So here, after the customer decided to buy something, we are moving to the planning stage. So after the customer signed, we are going there, we are like recording what's on site, we are planning how many modules to fit on the roof, we are planning where do the cable go in, who is going when, what screws do we need, what's the roof type, and what type of under construction do we need, what wall works do you need for your car. All those things need to be done and decided and planned, and we build custom software to do that at scale. We also handle logistics. So this amount of solar panels that we need, they are stored centrally in Germany, and we ship them to the construction site directly. That needs to be coordinated. Our software does that. Once all of that is done and the installation is planned, it also needs to be executed. And it needs to be executed in a certain way. It needs to be at scale. It needs to be at a certain quality. And it also needs to fulfill certain safety standards. That is why we built another app for that is called the Installation Manager, where we tell our construction workers what they actually need to do on site. Well, we first tell them where to go, and then we tell them what the customer, like who's the customer, how they can reach them, what the roof type is, and the result of the planning process. And you will see throughout this presentation how the software architecture behind those processes looks like. But before we do that, I want to clear out a stereotype that we actually riffed off on this title. So when you think of your regular construction worker, you know the situation where like two dudes like standing there and like looking at the one guy working. That's totally not the case. Like, this is a highly trained profession. They are under a lot of stress and a lot of load, and we need to provide them software systems that actually helps them doing their job.
Great, so let's try and make this a little bit more tangible. So let's say we're going on site for a PV installation. And to try to visualize what needs to happen on site, I just asked ChatGPT to tell me what it thinks there should be done. So there's a lot of steps here. It's pretty large. It's not exactly correct, but I didn't want to go into the correctness of it, just to show that there's a lot of things, right? We need to do a lot of things. And this is only for a PV installation, but if we go back to this image, we're not only installing PV systems. Maybe we can try a little game, and you can see how many of these items you can identify. But yeah, there's a lot. There's heat pumps, there's batteries, et cetera, et cetera. So we're installing multiple things. And not only that, but we also need to standardize the planning, we need to standardize the warehouse, so we need to basically provide a certain level, right? So we need to standardize this across all our branches. And 1,5 is not only in Germany. So we have multiple branches in Germany that do installations in all cities, but we also are in Australia, we're in Netherlands, we're in other countries as well, right? And we need to think about the fact that all these branches, they do things differently from one another. But we also want to provide some type of standardization, right? We want to make sure our customer is happy with the installation. We want to make sure that we're fulfilling this project to our standard. So to provide this level of standardization, we thought about doing this on 3, let's say, levels. The first level is our system workflow. So we define on our system what needs to happen to fulfill a project. This is what is needed by our operating system to actually work, right? So if we think about add order data, unless we have the order data, we cannot really do much with it, right? The system cannot really work unless it knows we need to actually install a PV system. And then we go a bit wider. So we think countrywide. In Germany, some things are done very differently. I don't feel confident enough to pronounce the German word, but there are different steps to it, right? And we want to standardize this across of Germany. We want them to do all these steps in all the branches, because some of them are also legal, right? They're required. And then we think, well, our branches say, well, we've always done it this way. You cannot come to us and just change everything, and they're right. We cannot do that. They do have some things defined. They do have a way that they work defined, and we need to support that as well. That's why we also say, okay, we provide a level of standardization across a branch. So we say a branch can expand this workflow and say what needs to be done in this branch to actually, fulfill their projects the way they're also used to it, or the way that they also want to, right?
Yes, so talking about fulfilling the work. So for this, we've written this tool, this app called the Installation Manager. Here you see 2 screenshots. And this basically shows the workflow that Sara was describing. This shows the work that needs to be done on site, right? We have those workflows, we have those standards. But this is just the one side of the story, because there's another side to the story, because that is what it should be done, and then reality hits. And reality, as you all know, not only in craftsmanship, is different and might look different. So what we pretty quickly understood is we need to separate what needs to be done to the stuff that actually happens on site. And what's important to understand, the value that 1K5 or that our systems create and that our installers create is not digital. It doesn't happen within our software. We are not the typical SaaS company where they would do their work in the software. They do the work in the physical world. They're mounting stuff, right? They're drilling holes and then putting something in it. It's not just a hole. And then we need to record the fact that stuff happened. And here you can see how we record those realities. And we record those realities in events. So here you see an event name, so pretty classical, right? We have a project started event. We have event data. All events always have an actor. All events always have, in this case, they have a project assigned to it. And they might also have attachments. So attachments can be any media type and any number of media types. Oftentimes it's a photo, because it's photo documentation of, oh, these are all the modules we mounted. Oh, this is how the cables are routed. This is the metering cabinet. Those types of photos we have as well. And as you could imagine, there's a lot of stuff that needs to happen in order to do that. And there's a lot of stuff that is relevant to the work on site, but it's not relevant if you think about the big picture of how a project comes together, right? It's not relevant if you look at the 1K5 group and say, oh, did the solar screw something happen at this one construction site? It's important for that construction site, but it's none of the key data. So we use this flow to separate what's important and what's not. And I think here we have a good example. So we have some key events. For example, the customer sign. That's a huge milestone in the installation, because that basically means the shift of liability, because they sign that we've done the work according to the contract. So that's a key event. So this is how we record reality. There is a difference in stuff that matters and stuff that doesn't, if you plug in a cable or if you're collecting a signature.
Perfect. So now we defined what needs to be done. We also have what happens via events. But we need to think about one use case, right? As Ole mentioned, the work doesn't happen in the software system. It happens in the real world. And when we define what needs to be done, we also need to account for different things, right? The installation of a PV module does not go the same for every customer. Certain things might pop up on site. So we need to account for this in our workflows as well. When we define what needs to be done, we need to also define what happens if we encounter, for example, previous damages. So this is when an installer goes on site, they need to inspect the site first, right? So they start inspecting, they go on the roof, and let's say they found previous damages. And this is something that we want to document. We want to know that this damage was there before. We want a picture. This is one of the attachments in the events that Ole mentioned. So we document these previous damages, and we also want to document, let's say, the damage severity, because it depends if it's a minor damage. It depends what needs to be done next, if it's a minor damage versus a major one. If it's a minor damage, you can just document it and then go ahead with the installation, but if it's a major one, you need to inform the order manager, they need to talk to the customer and schedule a new appointment, etc., etc. So different things need to happen. And we can set this up in our system. So we have built our workflows in a flexible enough way to basically set these automations right. So if we see at the first example, we say, okay, if there are any previous damages, and the installer said, yes, there are previous damages, then they need to document these. Right? This is something that needs to happen. So we are defining different tasks to be performed based on what happens on site. Right? So the work to be done changes on the go based on what pops up. And we can see this in the events. So we can see what happens in the real world once we've defined what to do. We can see then what gets done. So we see that they document the roof damages, and then they schedule another appointment. The customer confirms this other appointment, and then we go back to the installation and proceed as normal.
Yes, so when we continue and proceed with the installation, we are again recording these types of events. And now let's dive a little bit deeper into all the events things that we mentioned. So what does it look like? And you might also be wondering, why are we doing that? So let's take the next few minutes to talk about event sourcing and what is it, why are we doing it, and why we believe it's cool. So in order to understand the problem that event sourcing is solving for us, you need to understand the problem that exists when you use classical ORMs. So in a classical ORM, you basically have the mapping of a database table to a model, to a model and object in your programming language, right? And then you can alter the model, you can alter the attribute, and you can save it back to your database table. You do this 100 times, 1,000 times throughout the life cycle of a customer. In our case, it would be a project. You do this all the time, right? The things change, and it always records and represents current reality. At any given moment, you can understand the state of your application by looking at the database. What you don't know is the stuff that happens on the left-hand side. My right, your left, this side. So that information is gone. You never know how you arrived there. You have the current state, but everything that was there before is gone. You have no idea. And I've seen engineers putting timestamps everywhere. And yes, that is a solution, but I don't think that's how you should solve the problem. What if we project that state from the source state that we have anyway? So here you're seeing the same events again, or a simplified version of those events. And that is how we actually record the state. This is how we store information. And out of that information and the way we store it, we could actually get the same result. So we could just iterate through the information we have and create that projection or create that aggregate. So you go through this list of events, you go through that stream, you read an attribute by attribute and update the projection field by field. We'll see a more detailed example on how this works in a second. What's important to understand here, events are the single source of truth. You can't modify or alter them. And the projection that you generate, that is ephemeral. You can trash that at any point. It's a cache. You can also change at any point in time how you get to a result. So implementing new features all of a sudden looks very differently. But we'll talk about this in a second as well. Before we dive deeper, I want to mention other cool technologies that are not event sourcing, because all those words thrown around quite a lot. But I want to make sure we separate them correctly. So there's CQRS, that's the command query responsibility segregation. It basically means your application separates between when it reads and when it writes. It's a cool pattern, and it goes really well along with events and event sourcing, but you don't have to use it side by side. You can do the one without the other. The same is true for all the key value and time series databases or NoSQL databases. You can do that, and it goes nicely together, but you don't have to. And I want to emphasize this. If you want to start implementing events and event sourcing into your system, you don't need to go for this event sourcing database that someone shared on LinkedIn. If you can just use your regular database that you have already and start writing new rows into it, because all you need on the application level is a mapping function. That's all you need. So let's dive a little deeper, and that's the last point of event sourcing. Then we move back to this. Then we resume the story. So let's jump into these three more details here. So we want to jump into streams, aggregates, and projections. Before we do that, the operating system, our application, not a real operating system, is a Rails app. So we are using a fancy framework because it actually solves some problems we didn't want to solve our own. So the code examples you will see in a bit are actually using Rails Event Store. It also picked the wrong things off of Rails if you want a personal opinion, but we can do that over a beer and not on stage. So let's talk about streams. What's the stream? Well, a stream basically is a chain of events, right? You have multiple events, and I like to think of events in a stream as of things or events that sit on a string. It's a series of changes, and actually you use that every day when you use Git. Git is is exactly that, right? It's a series of commits, and your current checkout is basically the sum of that. So here you can see how it's done in Rails Event Store. You have to declare those events, and then you can basically create instances out of that and store them to the event store. That's really all it takes. It's fairly straightforward to do that step. So the next step are aggregates. So an aggregate, and we've talked about this, is basically the result when you read through this stream of events to build the resulting object. So here you see a code example of how that will look like. Here you would see that. Here you would see that how it looks like in Ruby code. Basically, here are two things that are happening. One is the declaration on the right side. So that's the first two things in the start and the send order confirmation part. This is how you would generate these events in the event stream. And then on the bottom part, you would see how you would read back those events and alter the state of your aggregate. What's also important to note, we have errors here, so we do validation before we actually write the events, because events always have to record the truth, right? So if it doesn't go along well, like if whatever you try to do is invalid, you shouldn't record the event. So validation now needs to live at that part. And last but not least, there are projections. So you might be wondering, like, what's the difference between projection and aggregate? Because quite often it feels very similar, but it actually is different in a way that in an aggregate, you're reading through a stream, like you're building up one thing, and a projection is more ephemeral, and it doesn't have to be limited to one stream. So here's one example of the order manager's overview, where we are basically building a new feature, and that is something I'm sure happened to all of you. So you have your app, you're using a regular ORM, like we all do, right? Not the entire operating system is based on this, just that part that we talk about. And then the PM walks into you and they're like, I want to understand how long does it take for a project to go from new to planning. And that's a feature request, right? You can go there and say, yeah, we can build this, and then you start tracking timestamp when it moves. And then you add a new column to your database, and then you have all that information going forward. But what about all the events all the projects that started before? That is lost data because you didn't record that. If we were using event sourcing, you have that information already. So you can generate new, or you can use the existing information and basically generate new insights based on that. So here you can see another code example of how you do that. So you're reading through all events of a single type and mapping them through to the names of the order managers, by that generating that report.
Okay, so let's bring it back to our setup. So this is trying to connect the dots. We talked about our workflows, right? We have our operating system service. Our users extend the workflow, so depending on the level that they're working on, right? This gets stored in a database. Very normal stuff. Then, depending on what happens to a project, this workflow might be expanded. So for example, if there is some remaining work you have to do, then this workflow gets expanded with the tasks to actually fulfill this remaining work, right? And we notify of these workflow changes through a pub subtopic. You will see a lot of Google Cloud icons here. This is because Google Cloud is what we use. So we have PubSub on there. We also have cloud functions. In this case, the cloud functions are in our case, they're very small satellite-type services. All right, so they get notified when the workflow update gets changed, and this gets written then to Firestore and to cloud storage for our application to use. This is our data source of the installation manager, which is built on Flutter, by the way. So yeah, so we write the workflows in Firestore, and in cloud storage, actually, we write the translations, because what needs to be done, we need to support this for multiple installers, right? And since we're not only in Germany, we're also in different countries, and our installers, we want to support whatever language they speak, right? So that's why we store our translations in cloud storage. Okay, so then they open, the installer goes, they open the application, they see the list of tasks they have to do, they start performing them, they start documenting them. This gets written to Firestore in a document. We call them workflow events. And this triggers another Cloud function processing this document. So it's basically the trigger is just a document is written. And this publishes the event then to a pub/sub. The topic of this pub/sub is the OS events. The OS listens to this pub/sub, and it stores these events in our database. So let's make it even more in-depth. So the publisher, our installation manager app, let's say the message is roof installation was completed. It goes to the topic. From the topic, we have multiple subscriptions, one of them being the operating system, listens to this event, stores it, and it does event sourcing magic with it. The whole flow of publishing to a pub/sub and listening to it is event-driven architecture. And why we have chosen this, I mean, you all probably know, but we just want to point out a little bit because we're using the words events a lot, so we just want to dive a bit deeper into what each of those means, right? So we're doing event-driven architecture because we want loose coupling of our services. So, for example, if our operating system changes their API, we don't want our Cloud function to know about it, right? We just wanted to say, hey, the roof installation was completed, do whatever you will with it. We can also build robust and flexible services, which means every service can scale on their own. So for example, if the operating system is listening to all the events, maybe it needs to scale up more than another service that is only listening to an installation completed event, right? So we can build them separately. We have this real-time instance response with event-driven architecture, so we can react on what happens as soon as it happens, and it's also easily extensible. It's easy to add new consumers. Whoever wants to react on an event can just subscribe and react to it. And one thing to keep in mind, because it is the same name, right? We're using events. These are two different things. So event-driven architecture is different from event sourcing. Event-driven architecture is how systems talk, how they communicate with one another. And event sourcing is how a system remembers, how it knows what happened, right? How it can go back in time. These are two different things. In our case, we use them together because they actually work very well together. And we have these defined domain set events, right, that are also interesting for our other consumers in the 1K5 landscape. So other services can subscribe to these events, can react on it. So it's very nicely coupled when used together, but you don't have to. You can just use event-driven architecture and then go and update a certain column in your model. You don't have to store events. You can also just store events without having any inter-service communication at all, right?
That sounds nice, right? Like, why don't you just take that architecture, put it into place, and run with it? There's one aspect of the story that we haven't talked about that is actually quite key. If you've ever driven with the Deutsche Bahn from Hamburg to Berlin, you might know what I'm talking about. We don't have fancy internet everywhere, and it doesn't even matter if we're somewhere in the outskirts on a roof, because we didn't manage to put telephone poles there, or if you're down in a cellar exchanging an old oil tank, where you have the same amount of signal that you have in the cinema, right? Offline is a thing. And we have to account for that. And we also have to account for that in our application.
So we chose Firestore. I hinted at this a little bit before. We have two main collections in Firestore. We have our workflows, what needs to be done. We have our workflow events, what happens on site. So maybe you can tell the issue by these two very big exclamation marks there. But Firestore comes with this pre-built-in offline functionality, right? It's super nice. The installer can interact with it. They can do whatever they want while they're offline. And then once they go online, everything gets synced to the cloud and magic, everything's done. What happens, though, is that sometimes you have multiple installers working on the same installation, documenting different parts of it. And what we were doing was, so we were going with this event architecture, right? We were storing all the events in the workflow events, and they were getting saved in the operating system just nicely. But in the installation manager, when we were showing what needs to be done and what has already been done, right, we were actually updating the workflow document. So we were saying, okay, this task that needs to be done now is done, right? So if you have 2 installers, one does 2 tasks, the other one does 3, they're both offline. At the moment when they go online, one of those is going to win. You will not have 5 tasks done, you'll either have 2 or 3. So what did we do to fix this?
Well, dealing with eventual consistency is hard, and it's a solved problem, right? Like, why are we even talking about this? Well, what we did in order to fix that is, I told you about how we use events to use these aggregates and these projections, and how we use events as a source of truth to actually build up stuff. We didn't do that in the mobile app. In the mobile app, we actually did the other thing, where we wrote the same state into 2 data stores, and then had multiple sources writing to the same data store, which is not the best idea, right? Staying on stage here right now, it makes like a duh, he could have known, yes, you could have known, and actually, now we learned, right? It's always the story of learning. So what we did now is we are only writing ever once, we are only recording history once, we are only having a single source of truth, and we are writing to those events. And if we want to show the state and the result of these events, we are using the same technique we used in the backend already. We are going through this list of events and project the state and aggregate the state. And something I want to point out, because I think it was actually most funny, when we were discussing this issue and how we want to solve it, and we should do the same thing, I wanted to sound smart and throw in like, yeah, we should do CRDTs. Like, there's the conflict-free replicated data types. It's a thing. It's I don't know, there's 1,000 blog posts out there that discuss that fact that it can solve eventual consistency for you. And then when we actually dug into it and learned, like, can we actually use that? Like, does it actually make sense? Because I only throw in buzzwords because that's my title. We learned that we're actually doing it. So one replication, conflict-free replicated data type is a so-called append-only list. So that's what we're doing here, right? We are using a CRDT without knowing, so we didn't invent it, in our application to solve eventual consistency for our app. What do we want you to remember from this talk? Because it's an unfair advantage here. It's like the 2 brains of us on stage, and you all only have 1. So we try to sum it up for you a little bit. The important bits. So the first important bit is that change is hard, and that's okay. That's hard for the branches we put our software on. It's hard for software engineers who are seeing a new pattern emerging that looks and feels very differently to what they're used to.
Yeah, we also want you to remember event-driven architectures, different from event sourcing. Again, you can use them together, but it's good to make an explicit choice of when using one and when using the other. Despite them working very well together, you might not need event sourcing. You might also not need event-driven architecture. So it's good to remember that despite the name being slightly similar, 2 very different things.
And last but not least, what we decided to put on the slide is to keep a single source of truth. And I mean, that's kind of boring, right? How can this be the main takeaway of this presentation? There's something that they teach you in computer science, like basically 101. And it's funny because, like, we are all trained professionals in our team, and we missed that point, right? And it's not because, like, we deliberately decided to just forget one of those basic principles. Sometimes in the day-to-day work, you might not have the time to take a step back and think about the stuff that you're doing. And that is the takeaway here. Like, take a step back and remember the basic principles and adhere to it, because otherwise it causes a lot of pain. Because that's what happened to us in this very example. So that is how 1K5 and the virtual assembly line in 1K5 operates in the field. There's a lot more to 1K5, and maybe there will be more talks out there at a different point in time. But for today, that's all we got. Thank you so much for your attention.
Thank you.